Hello and welcome to the Security Dev Room. Hope you had a nice lunch and are ready for a talk by Hanno Beck, who's going to talk about desktop security. Please welcome Hanno.
Yeah, hello. So I hope you have like your pitchforks ready and are really angry because I chose this very provocative talk title. But I want to talk about a few issues that I think they are. Huh? Hello? Oh. Like, do you hear me? It's okay. Let's. Hello? Hello? Okay. Okay. Yeah, I want to talk about a few issues with Linux desktop security, and I mainly want to get you angry, but not angry at me, but angry at the situation, and you should do something about it. Kind of the idea for this talk I got when this is a quote from Chris Evans, who found a couple of security issues with common Linux desktop systems, where he said, yeah, this was too easy. It should not be possible to find a serious memory corruption vulnerability in the default Linux desktop. And there he said that, like, this is not the kind of situation that occurs with the latest Windows 10 default install. Is it possible that Linux desktop security has rotten? So he published a couple of blog posts, and the first one was an exploit against the parser of Nintendo sound files. So Nintendo sound files, that is like this. Sorry, it's not so loud, but yeah. So it was an exploit against GStreamer, which has a parser for Nintendo sound files, which are files extracted from NES games, which is of course important because like we like to be able to listen to this Super Mario music. Interesting there was that it was in the thumbnail parser, so even if you're just opening a folder in the file manager with such a file that had this exploit, it could exploit your system, and an attacker could gain control over your system. It was in Ubuntu 12.04, which is kind of old, but it's still supported. Also interesting here is that these Nintendo sound files, the player here is basically a mini emulator that's emulating the functionality of the Nintendo sound chip. And that means an attacker who like sends you such a sound file, he can basically execute some kind of code, and that makes it much easier to bypass certain exploit mitigation techniques. And also interesting, to fix this, you could just delete the plugin, like the file, and you could still play these Nintendo sound files because there were two decoders for them in GStreamer. So, yeah. Then the next exploit was against flick files. Does anyone know what flick files is? Have you generated them? Or very few hands. So they come from a software called Autodesk Animator. It's actually free software, so the code is available under a BSD license. It's a tool that was popular in the 90s in DOS to create animations. I have such an animation for you. So this was mPlayer, and but the exploit was in GStreamer. But if I try to play this with Totem, which is using GStreamer, it doesn't work. So it had a decoder for it, which had an exploitable bug, but it seems it doesn't work. So, yeah. But mPlayer can play it. Now, there are a few interesting things came together. So first of all, there are a couple of browsers that automatically download files without asking any questions. So if you click on a download, they will just place them in the downloads folder. This is, for example, Chrome and Epiphany and Conqueror. Conqueror, I tested earlier today, it doesn't even show you any kind of dialog. So it just downloads the file and you don't see anything. And if you don't even have to click on the download because that a JavaScript can do for you. So what that basically means that if you're using one of these browsers, then any web page can create a file on your on your file system, which is interesting, and I think also something where you could think more about it, like whether that could be exploited in interesting ways. Also, but important here is also this is not Linux specific. Chrome does the same thing in any operating system. But then there's a tool called Tracker, which is part of the desktop search functionality in GNOME. And it automatically indexes new files created in your home directory, which includes your downloads directory. So the exploit was basically, yeah, a web page could give you this flick file. It gets automatically downloaded, it gets automatically indexed by Tracker, and then the exploit can run. And there was a comment from the Tracker developer below this blog post where he said, yeah, the GStreamer guys were extremely fast in fixing it. Okay, great. You could claim that other libraries used for metadata extraction are just as insecure, but that really be bugs in these libraries to fix. Now, from a security perspective, I have a problem with this way of seeing these things because, like, if you look at the libraries Tracker is using, it's like GStreamer, FFmpeg, Flag. Okay, these are more popular, but also things like I don't know. I didn't know what libITPC data does. I looked it up. It actually seems to be some kind of tagging functionality for JPEGs that's non-standard. Yeah, so there are a lot of libraries, and like maybe half of them have decent security, and the other half, like, nobody ever looked for security. So I think if you're writing a tool that's using all these libraries and exposing them to untrusted data, you kind of have a responsibility to care about that. And you cannot just say, yeah, this is a bug and we'll fix it, because like there will always be another bug in one of these libraries that can be exploited. Yeah, so like if you can exploit any of these, you basically can exploit the system of a Linux user right away from a website. It's not just Tracker. Like KDE has a similar tool which is called Baloo, and it basically has the same issue. And also, as I already mentioned earlier, like thumbnail creators have kind of a similar problem. They are not getting executed automatically, but they are getting executed as soon as you open a folder with your file manager. So also the file manager here creates a huge attack surface. So I think we have two problems here. One is like we have some automation here that's, I think, sometimes done a bit in a thoughtless way. Like, okay, if you click on a download, it's nice if it just gets downloaded, no more dialogue, that's confusing people. And you have this desktop search and you automatically index stuff, which may be an interesting feature, but it creates a huge attack surface. And then the other issue here we have is that there's a tendency, and I think in the free software community, that people tend to use all kinds of libraries to support as many different file formats as possible. And many of these libraries are just of very varying quality. So what could we do about this? So one idea is to use some kind of sandboxing so that you're kind of isolating the process. So even if there's some exploit, it is kind of limited in the impact it can create. And these things, something like such a desktop search where you have a very isolated process that's just getting some input file and extracting some data, it's a very good target for sandboxing. And actually, after these events, like Tracker implemented sandboxing, which I think is great. It happened really fast, based on libseccomp, and yeah, that's one way of reducing the impact. And as long as like the sandbox doesn't have vulnerabilities, which unfortunately also happens very often, this creates better security for these situations. But as I said, yeah, KDE has a very similar tool, and they have no sandboxing yet. And also the same thing needs to happen for thumbnailers and similar stuff, which has a large attack surface. Then there are several exploit mitigation techniques. So based on the idea that there will always be security vulnerabilities, a lot of technologies have been developed to just make it harder to write exploits. And typical things are stack canaries, non-executable memory pages, address-based layout randomization, and kind of a newer idea is called control flow integrity. So the first two, we usually have them today. So stack canaries, that's with GCC, you have a flag fstack protector, and I think all major distributions use this by default these days. And non-executable memory, that's these days is a feature of Intel CPUs, so that's usually available. With ASLR, it's a bit more complicated. So ASLR, the idea there is that you're just loading code and data on random addresses into memory. And the reason for that is that many exploits rely on the idea that you can override some address for some code and then jump into some area in the code. And if the addresses are random, then the attacker doesn't know where there's any valid code in memory. So that's a pretty strong protection. And the Linux kernel had ASLR support since 2.6.12, so quite a while ago. But if you want the ASLR to work, you need the code needs to be compiled in a certain way that it's possible to load this code into random places in memory. So and the executable also needs some special properties. So you need so-called position-independent code and position-independent executables, which again are compiler flags, and PIE is a linker flag. And here, that's a bit of a sad story because like Linux distributions have been extremely slow in adopting this. So the current state, it's gotten much better in the last couple of years. Like Ubuntu introduced it last year, Fedora in 2015. Debian is working on it, and as far as I heard, for the next version, it should be enabled by default. OpenSUSE only enables it for a few packages. Gentoo only if you use hardened Gentoo. So this is something that should just be enabled by default everywhere. It has like, on 32 bits, there was a bit of a problem that it had a significant performance cost. On 64-bit, it basically doesn't matter. This is, the performance impact is very low, and it provides a very strong protection against many kinds of exploits. So for other distributions that haven't enabled it yet by default, please do that. Windows had this since Windows Vista, so quite a while. And modern Windows is already, Microsoft is experimenting a lot with more modern exploit mitigation techniques. I'm not an expert in this, but so I cannot tell a lot of details, but a lot is happening there. However, these are similar to the Linux situation. These are things that depend on things like compiler flags. So not all applications use this. So it depends on the application. It depends on configuration. Sometimes you also have things like that antivirus applications disable this because whatever. So a mixed situation as well there. Then there's the idea of, with all this C code, maybe we should use other programming languages, and Rust gained a lot of traction lately. So, some people say, let's just stop using the C because like C is just full of these memory corruption issues, and we should just rewrite everything in Rust or maybe some other language. Maybe this is the right thing to do, right? But it will take some time, and we'll probably have this C code laying around for a while longer. So, But actually, GStreamer already supports writing plugins in Rust, so that's a good thing. So maybe someone wants to rewrite the Nintendo sound file parser or the Flick parser in Rust. That would be a good thing. Or can we just, as the tracker developer proposed, just fix all these bugs? So, I looked a bit at GStreamer, and GStreamer is a software that's extremely prone to memory corruption bugs. It's written in C, okay, and it has parsers for a lot of complicated file formats, like really a lot. I don't know, like 100 or something. And we have a lot of similar software, like, okay, FFmpeg is also a media parser, ImageMagick, which supports all kinds of image formats, also browsers, but browsers tend to have bug bounty programs and better security teams, so usually this stuff is... But also things like Wireshark or TCP-dump. Maybe you've read it that TCP-dump recently had a release with, I think, like 50 CVEs. I think most of them were reported by me 2 years ago. So we could do some fuzzing, and because many of these bugs can be trivially found if you use a modern fuzzing tool. By definition, you can never find all the bugs with fuzzing, but it's really like, I rarely see a memory corruption bug where I run a fuzzer on it and I don't find it. So if you have many memory corruption bugs, then it basically means nobody ever used a fuzzer on this software. And yeah, the typical tools you use these days, American Fuzzy Lob is very popular. Another one is libfuzzer, which is from the LLVM developers. And a tool that can very well be used in combination with fuzzing is Address Sanitizer, which finds memory safety issues that don't crash your application. I found 20 memory safety issues, so some of them were crashes, some of them were invalid memory reads. I should say here that they are not necessarily all exploitable. Probably most of them are not, and I had a bit of the discussion with the GStreamer developers who said, hey, why did we get 20 CVEs for GStreamer? And I said, yeah, well, today the policy for CVEs is that they get assigned very easily, and basically every time a library does some invalid memory access, it gets assigned a CVE and is considered a security vulnerability, which does not mean that it's necessarily exploitable. So this is quite a bit, but it's also a message I want to give here is that this is doable. Like, you can make a software like GStreamer much more secure. And like I continued running the fuzzer, and I think now it ran for 7 days without finding another bug. So you can get to a state where it gets much harder to find these memory corruption bugs. But there are dependencies. Like, GStreamer is not just the GStreamer software itself. It's using a lot of third-party media libraries, like libopus, FLAC, libvpx, or also things like wavpack, game music, emu, libsitplay. Do you notice the difference between these two lines? Like, the upper ones are libraries that are used by browsers, which usually means they are much safer because browsers pay you a lot of money if you find security vulnerabilities in these libraries. The lower line are more the obscure stuff, like wavpack is the old, basically pre-FLAC lossless file format. Game music emo is for all these Nintendo sound files and other gaming consoles. Schrödinger, that was a format by the BBC. They've basically abandoned it. It has security vulnerabilities, but nobody's maintaining it. Libsitplay is for C64 file. So these lower ones are much more problematic from a security perspective. So while I think we can probably fix most security bugs in GStreamer, doing the same thing for other dependencies is really hard, and I'm not sure. Like, I'm trying, but it's really a lot of stuff. I want you to help me. So, is Linux less secure than Windows? Someone made an interesting comment below an article I wrote about this, saying that, yeah, you don't have something like Tracker in Windows, except if you install an antivirus software. Because an antivirus software also has a lot of parsers for complex file formats. And usually the code quality is also really bad usually. So maybe the conclusion could be if you install an antivirus on a Windows, you get the same insecurities you have on Linux. And then this shocked me a bit. There was a bug found by a guy, I cannot say his name correctly, so I won't even try it. He found a code injection vulnerability in Apport. It's a tool from Ubuntu which is used to handle crashes. and it produces a crash file, and you can like, if you double click on such a crash file, it gives you some info. Okay, I'll do it quick. And then he asked some exploit dealing company who is like selling exploits to governments or whoever, and they offered him $10,000 for this bug. And so this means basically there's someone who thinks it's worth $10,000 to attack Ubuntu users. So you could, many people may think Linux desktop, that doesn't really matter. I mean, nobody's using a Linux desktop. I mean, I do, but not a lot of people. But this really means like this matters. So yeah, Linux desktop security matters, and we have to fix this. Thank you.
Thank you, Hanno. We have time for questions. Raise your hand if you want to ask something or comment.
Hello. Do you have any thoughts concerning the Cubes desktop?
Okay, the question was if I have thoughts concerning Cubes. I haven't looked at it personally, but the idea of Cubes is to have a very strong concept of sandboxing. Maybe that's the right way to go. What I don't think is sometimes people think sandboxing is the whole solution, and I don't think that's the case, because even if you have sandboxing, you will always have potential to exploit things that run in the same context. So even if we have sandboxing, we should still make our software more secure.
More questions? Raise your hand. Maybe we can have a poll. How many people think Linux desktop is more secure than Windows 10? So, fun. Not even half. So interesting.
Yeah.
More. There's a question over there.
So about Tracker, does it run with permissions enough to do a lot of harm to the system? Does that count?
Yeah, so like the old version of Tracker ran with just the user account's permissions, so it had full access to everything the user does. Like as I said, the new version now is sandbox using libseccomp. I hope that's done in a proper way and will restrict it to just this process.
Thank you. There's another question. Raise your hand if you want to ask something.
More a comment than a question. Thanks, Hanno, for a very interesting talk, and thanks for reassuring me that using my set shell as my main file manager is a very good idea, actually.
Yeah, but the thing, I want the Linux desktop to be an option for average users, and they won't use a shell as their file manager. Yeah.
Anyone else? Okay, let's thank Hanno for the talk.